Hi everyone. We are presenting our paper, Towards Unifying Medical Vision and Language Pre-Training via Soft Prompts. Nowadays there are large-scale medical data, tabular data, time series data, image data, text data, and structured data. Among them, image data and text data are two critical ones. More importantly, they are always pair-collected. We target at the Medical Vision and Language Pre-Training (MEDVLP) problem. It aims to learn the representations of vision and/or languages in the medical domain from medical image-text pairs. The field of MEDVLP faces several limitations, where prior works on MEDVLP either focus on learning the joint representation of vision and language, we call fusion encoder, or b. learning the visual representations from texts, we call dual encoder. Our contributions are fourfold. First, we introduce a simple approach to unify the two MEDVLP paradigms, fusion encoder and dual encoder. Second, technically, we introduce two prompt pools for vision and language, respectively, from which the model will retrieve as input prompts when one of the modalities is missing. Third, we conduct a comprehensive evaluation on a variety of medical vision language tasks, including unimodal, cross-modal, and multimodal tasks. Last, we conduct analysis to analyze the effects of different objectives. Practically, there exist two typical types, i.e., the fusion encoder type and the dual encoder type, depending on whether a heavy fusion module is used. The former is superior at multimodal tasks owing to the sufficient interaction between modalities. The latter is good at unimodal and cross-modal tasks due to the single modality encoding ability. In previous modeling, for dual encoder modeling, it requires two models to accept image-only and text-only inputs. For fusion encoder, it requires the model to encode the image-text inputs into a joint space. In our modeling, to make the backbone model compatible with variable size and heterogeneous input, this work proposes a simple yet effective approach, namely using prompt, PT, as a placeholder for missing modality. Therefore, the model naturally accepts two inputs, visual and textual embeddings, which is by definition compatible to inputs with image-text pairs. For image-only, text-only inputs, we propose to introduce visual textual prompts to enable the backbone model to perceive the missing input in a specific modality. Owing to the unified image and/or text input formulation, we can adopt pretext tasks of both fusion encoders and dual encoders. Specifically, for the masked language modeling and image-text matching objectives, the model will input the image and text to the model naturally. For image-text contrastive, the model will encode image and text separately, and when one of the modalities is missing, the model will retrieve the prompts of the other modality to fill the missing input. Therefore, it can learn the three types of objectives with a single model. We conduct experiments on three types of tasks: unimodal tasks, including image or text classification, text summarization; cross-modal tasks, including image-to-text generation and cross-modal retrieval; and multimodal tasks, including medical visual question answering. Experimental results show that the pre-trained model can achieve promising performance across different tasks and datasets. By conducting ablation study on different pre-training objectives, we have the following observations. 1. The objectives of fusion encoders, i.e. MLM and ITM, guide the models, i.e. ID3 and 5, to the more powerful multimodal learning than other models without them. 2. The image-text contrast objective of dual encoders assists the models, i.e. ID4 and 5, in learning the unimodal image features and the cross-modal representations. 3. It is interesting to note that the ITC objective does not promote the performance of the unimodal text classification task. Thanks for your attention. If you are interested, you can read our paper for more details.